Hello my dear students, how are you studying? I hope you are doing well. Do you have the tables that were given in our previous classes? Today we need those tables. If you don't get by heart, then it will be difficult for you to understand the lessons that I am going to teach you. So anyway, if you don't by heart, please try it so that you may by heart it as soon as possible. So the first question for today, you see in the whiteboard, the question is here. Name the following compounds. Roman number 1, copper hydroxide, CuOH2, FeS, ferrous sulfide. Roman number 3, Fe2O3, Roman number 4, FeO, Roman number 5, NaHCO3. You are given 5 compounds and you have to write down the names of these compounds. In the previous case, we are given the name of the compounds and then we used to write the chemical formula of the compounds. And today we are going to do just the reverse of that. Means we are given the chemical formulas and now in turn we have to write down the chemical names of these compounds. Just the reverse of the previous case. So how will you do? Answer. Roman number 1. CuOH2. So this is the chemical formula given to us and we are going to write the name of this particular compound. How to write the name of the particular compound? Whose symbol is this? Look, Cu. Cu is a symbol for copper. And whose symbol or whose formula is this? OH? OH is the formula of hydroxide. This is the formula for hydroxide and this is the symbol for copper. And from this chemical formula, can you tell me the valency of this copper? The valency of copper is written on the side of the hydroxide. And the valency for hydroxide is written on the side of the copper. But it is not shown here. It means the valency of OH is 1. 1 is not written. 1 is usually omitted. So no need of writing that 1. But since valency for copper is 2, we cannot omit it, and we see the valency of copper on the side of OH here. So from the formula itself, you will understand the formula of copper. But you know, copper has 2 valencies. Valencies of copper, Cu, 1 and 2. The methyl copper has 2 valencies, 1 and 2. 1 is called lower valency and 2 is called higher valency. So for naming the compounds, we have 2 ways of naming. First I write like this. Since we know the valency of copper, during the time writing the name of this chemical formula, we can write the name of copper just mentioning the valency of the copper like this. Copper 2 in Roman figure. Copper 2. This 2 means valence 2. But here you cannot write. Here you have to write the Roman numeral only to show the valency of the methyl copper within bracket like this. Copper 2. And then you come to this part. What is this? This is hydroxide. Copper 2 hydroxide. So this is the name of this compound, and the name of this compound we can write the second another name. We can write the name in 2 different ways. In the first one, we show the valency of copper by using the Roman numerals and written within the bracket. And another type of name of this compound is cupric hydroxide. This is another name. So now you can call it copper 2 hydroxide or cupric hydroxide. Actually, the symbol for copper Cu is derived from its Latin name cuprum. In the first name, we do not use that cuprum. Instead, simply we use the English name copper. In such a case, we have to show the valency of the metal. Valency for copper is 2. Because of that, here we are writing copper 2 hydroxide. And in the second case, we are not using the English name. From the Latin language, the name of copper is cuprum. From that name, cuprum, since copper has two valencies, 1 and 2. 1 is called lower valency, 2 is called higher valency. If valency 1 is used, then you have to write cuprous for lower valency. And for higher valency, we have to write cupric and with RIC, cupric. And for lower valency, we have to write cuprous. But here, the valency for copper is 2. That it means higher valency. So we are going to use this word cupric, not cuprous. If the valency is 1, then you have to change this from cupric to cuprous. But here, since the valency given is higher valency, no efficiency, so we have to write cupric hydroxide. Now let us see the second one. Second compound is FeS. So by observing the chemical formula, could you tell me the valency of iron and sulfur in this case? So here you see valency of sulfur, the normal valence of sulfur is 2, and valency of sulfur should be written on the side of iron. And for iron, it has two valencies. For iron, there are two valencies, 2 and 3. For iron also has two valencies, valency 2 and valency 3. So let's assume that the valency of iron is 2. Then we have to write another 2 on the side of sulfur. So this is the valency for iron and this is the valency for sulfur. While writing chemical formula, the valencies, if we can cancel, then we can cancel like this. Means we can cancel the valencies. And after cancelling, now we have 1 iron atom, 1 sulfur atom. No need of writing 1, 1. 1 usually not written, it is omitted. So we can write FeS. Then you compare with this. Here also FeS, here also FeS. Then from this we come to know that in this compound, the iron that we use is of valency 2, not valency 3. That means lower valency. So how will we write the name? First, let us write down the name of this compound showing the valency. Then we have to use the word iron. Iron 2 sulfide, not sulfur. When this S is in the form of element, then we used to call it sulfur. But when it combines with another atoms and form a compound, then you cannot write the name sulfur. It has to change to sulfide. All the non-metals, they have to change their names when they form compound or they form molecule. So now you write iron 2 sulfide. Another name of this compound, iron is the English name. In Latin name, this element has a name that is called ferrum. From the word ferrum, we can make two, ferrous and ferric. Ferrous, ferrous and ferric. Ferrous for valency 2 and ferric for valency 3. The name which ends with RIC should always be for higher valency. The name which ends with OUS should be for lower valency. So here, the valency of iron, as we know, is 2. That it means we are using this lower valency. So, using this words, if you want to write down the name of this compound, you have to select this one, because in this case, the valency of iron is 2. That is the lower valency. So now how will you write it? Ferrous. FeRrous, ferrous sulfide. This is another name, like this. And let's continue the third one. Fe2O3. Now from the formula itself, you will come to know the valency for iron is 3, valency for oxygen is 2. It is confirmed 2 and 3 cannot be cancelled. So they are all showing here. Since we are using the higher valency of iron, then how will you write? First, let us write showing the valence is iron 3. Because here the valency of iron is 3, so we are writing iron 3. This is symbol for oxygen, but now this oxygen is in the form of a molecule, so you cannot write as oxygen. It should change into oxide like this. Or another name is, since in this case the valency of iron we are using is 3, that means we are using the higher valency. If the valency is the higher valency, then we have to use this name, ferric, not ferrous. So now how will you write it? Ferric, F-E-R-I-C, ferric oxide, like this. This is another name. And then Roman number 4, FeO. Here again you will come to know valency for oxygen is 2, only one valency. That valency of oxygen should be written on the iron side, but it is not written. It means here in this case we are using valency of iron 2. Valency of iron 2 on this side, valency of oxygen 2 on this side, 2 cancel, and afterwards you have FeO. So in this case the iron that we use is of valency 2. Then how will you write? Iron 2 oxide. Or another name is, since valency is 2, it is lower valency, so we have to use this word ferrous. F-E-R-R-O-U-S, ferrous oxide. Like this. So now we have to give the answer of Roman number 5. Let us remove all these things and let us continue. How we write? Roman number 5 answer, NaHCO3. Na is a symbol for sodium metal. ISCO3 is a polyatomic ion. We call it bicarbonate or hydrogen carbonate. Then how are you going to write the name of this chemical compound? You have to write sodium first. Sodium bicarbonate. Bicarbonate. Or you can write sodium. The name of this polyatomic ion is bicarbonate as well as hydrogen carbonate. You can call it bicarbonate. Also you can call it hydrogen carbonate. So using the word bicarbonate we make the first name. And the second name using hydrogen carbonate you can write like this, sodium hydrogen carbonate. Like this. This is the name. So do you understand how to make chemical names of the compounds if their chemical formulas are given to you? And I think you understand it. And then now let's come to the second question. Find the number of atoms present in Roman number 1, Na 2 SO4, and Roman number 2 CO3, 2 negative charge. Let us see. Let us make the answer here. Answer for question number 2, second question. Roman number 1, NH4, first bracket, 2 SO4 molecule. This is a molecule, this is not an atom, this is not an element, but this is a molecule of a compound. The name of the compound is ammonium sulfate. This is symbol for chemical formula for ammonium, and this is chemical formula for sulfate. So you can call it ammonium sulfate. Now we are going to find out the total number of atoms present in this ammonium sulfate molecule. number of atoms present in NH4 2SO4 molecule. How do you do? You look the chemical formula carefully. Within this first bracket, we have 1 nitrogen atom and 4 hydrogen atoms. That it means together 5 atoms are within bracket. And outside the bracket, what you have? You have the number 2. That it means NiH4 is 2 in number. And since in one NiH4 there are 5 atoms, so you can find out the number of atoms present in 2 NiH4, 5 into 2. It's very simple. So you have to do like this. Inside the bracket, 1 for 1 nitrogen atom. I'm just adding the number of atoms present here for different elements. For nitrogen, only 1 atom. Plus, for hydrogen, how many atoms are here? 4. It is indicated by this number, 4. It is written as suffix 4. 1 for nitrogen and this 4 for these 4 hydrogen atoms. And outside bracket, what you have? We have the number 2. That it means this type of NiH4 is not single, but it is double. So you have to multiply it by 2. And after that, you use plus sign. And what is this? This is symbol for sodium atom. How many sulfur atom? How many sulfur atoms are here? Only 1. So you put 1. Plus the last part, O4. This means there are 4 oxygen atoms. So you please write 4. Then total now. 1 plus 4 is equal to 5. 5 into 2 means 10. Plus 1 plus 4 means 5. Total 15. That it means in one molecule of ammonium sulfate there are 15 atoms together. Then let us see the next one, second one. What is that second one? CO3 to negative charge. What is this? Is it an atom or a molecule or an ion? This is not an atom, this is not a molecule, but is a polyatomic ion. So you can write here ion. Total number of atoms present in CO3 to negative charge ion is equal to. Let us find out. What is this? This is symbol for carbon. And since no number is written, that it means there is only 1 carbon atom. So you put 1 for 1 carbon atom. And then next, this is symbol for oxygen. And for this symbol oxygens, we have a number 3. That it means there are 3 atoms of oxygen. So you please put 3 like this. And what about this 2 and 1 negative sign? This simply indicates the charges that is carried by CO3 ion. That it means 1 carbonate ion carries to negative charge. While calculating number of atoms of carbonate ions, these 2 negative charge, it has no role to play. So we are not going to count it. So we have to count up to this only, because this 2 negative, it means the total charge of 1 carbonate ion. For finding total number of atoms, it is not necessary. Therefore, how much you got? 4. So in 1 carbonate ion, there are 4 atoms. And don't forget, this type of numbers and sign has no role to play while calculating the number of atoms present in that particular ion. So like this, we have to calculate the number of atoms present in a molecule or present in an ion in the same manner. So now let us continue our lesson. Let us see some definitions which are also very much necessary for you. So you know your next question will be, what is molecular mass of a molecule? We talk about molecule of substances, and molecule also, they have their own fixed mass, and we are going to define what molecular mass of a molecule is. You can write like this: molecular mass. Simply. Molecular mass is also a relative mass of a molecule. Why you use the word relative? Because we are not going to find out the mass of any molecule in different ways. But we are going to find out their masses in connection with the mass of C12 atom, taking as 12U. So this standard C12 atom is used as a standard mass for calculating atomic mass of any atoms or molecular mass of any molecules. Because of that, since it is related to the mass of C12 atom, we used to call it relative. So molecular mass is also relative. So when you write the definition, you have to write like this: the relative mass of a molecule. As compared with the mass of one C12 atom. Taking 12U is defined as the molecular mass of the molecule, like this. The relative mass of a molecule as compared with the mass of one C12 atom, taking 12U. Taking 12U means the atomic mass of C12 atom is taken as 12U. U means unified mass, atomic mass unit. It is also equal to atomic mass unit. So you compare the mass of that molecule with the mass of this C12 atom, but don't forget, you have to take 12U as the atomic mass of C12 atom. You compare it with the molecular mass of that molecule, and then the resulting answer is to be the molecular mass of that molecule. Because of that, we used to write the word relative, since it is related with the mass of C12 atom. So this is the definition. Or sometimes you can write the definition very simply, like this: the molecular mass of a molecule is the total mass of all the atoms present in the molecule. The molecular mass of a molecule is the total mass of all the atoms present in the molecule. Like this also you can give it, but it's better to give like this. But anyway, I'm writing another definitions to make you understand more. But in the examinations, you write the first one, and the second one you keep it in your mind to make more understand by yourself the definition of molecular mass. And next, let us see this. Define gram atomic mass, short form, and Roman number 2, gram molecular mass. You can write in short form like this, GMM. So this is also very important. We are going to use it very frequently, this gram atomic mass and gram molecular mass, for the remaining part of this lesson. So let us see, what are these gram atomic mass and gram molecular mass? Answer. Gram atomic mass. Gram atomic mass. Like this. We already learned about the atomic mass of an atom. Atomic mass of an atom is measured in atomic mass unit, and it is also called unified mass U. But when we want to know what is this gram atomic mass, it's very simple. Atomic mass can be expressed in terms of atomic mass unit, that is in unified mass. That we already learned it. And if you express atomic mass in terms of grams, numerically same as that of the unified mass, but what we have to do is we have to change the unit only. Atomic mass to gram, we have to change it. So the atomic mass that is expressed in terms of gram, that is called gram atomic mass of the atom. Only one sentence. The atomic mass expressed in gram is called gram atomic mass of the atom. So gram atomic mass is also something like atomic mass, but it should be expressed only in grams. So now let us see an example. Let us take an atom sodium. Sodium symbol is Na, sodium atom. Let us take. Atomic mass of sodium atom is equal to how much? You must get by heart the atomic mass of some of the common elements. We have around 20 common elements. If you can by heart the atomic masses of these 20 common elements, then it will be very helpful for you. So this atomic mass, you have to get it by heart. There is no other option. Without getting by heart, you cannot do anything. So what is the atomic mass of sodium? It is 23 AMU, or simply you can write 23 U same. 23 MU and 23 U are same. This is new name and this is old name. Atomic mass unit and unified mass. Therefore, gram atomic mass of sodium atom is equal to 23 gram, like this. So you understand, atomic mass of sodium atom, gram atomic mass of sodium atom, numerically they are same. What is the difference? In case of the actual atomic mass, we express in terms of atomic mass unit or unified unit. Atomic mass unit and unified unit are same. But in case of gram atomic mass, the same number is still there, but this AMU or U is changed to gram. That it means atomic mass is expressed in terms of grams. That is called gram atomic mass. So like this is the only difference. So once you know the atomic mass, then it is almost same knowing gram atomic mass of that atom. And let us come to the second one, gram molecular mass. Gram molecular mass. GMM. We can write like this. This is also almost the same as that of the gram atomic mass. Molecular mass expressed in gram is called gram atomic mass of the molecule. So you can write the molecular mass expressed in gram is called gram molecular mass. Of the molecule. So definition of gram molecular mass and definition of gram atomic mass are almost similar. If you know the definition of gram atomic mass, then you can give the definition of gram molecular mass. The word atom is changed into molecule, that's all. So now let us give an example. Let us take a molecule. This time we cannot take atom because this is molecule. Let us take water molecule. Water molecule. Chemical formula for water molecule is H2O. Let us see for this one. First, let us find out molecular mass of water. Molecular mass of water equal to, how will you find out molecular mass? You have to add the atomic masses of all the atoms that constitute the molecule. So in water molecule, actually water molecule is constituted by combining 2 atoms of hydrogen and 1 atom of oxygen. Altogether there are 3 atoms. So now since the atomic mass of hydrogen is 1, so for 2 hydrogen atoms, how many we have? 2 into 1. U, unified unit, plus atomic mass of oxygen is equal to how much? 16U. This also you have to get by heart. Then how much you will get? 2 plus 16 means 18U. This is the molecular mass of water. Therefore, gram molecular mass of water equal to the same number. Here is 18, here also 18, but this unified unit U must be changed to gram. This is the only difference. Only the unit is changed, but the numerical values remains the same. Because of that, when we give the definition, gram molecular mass is the molecular mass of the molecule expressed in gram. Like that, we give the definitions. So now I think you understand what is gram molecular mass, gram atomic mass, etc. These are all important. So anyway, you try to know it. And lastly, I like to make a table for atomic mass of some common elements. In the next class, we are going to learn mole concept, a very important part of this chapter, and also very important not only for class 9 but for the higher classes 10, 11, 12, etc. we're collecting all the minerals required for mole concept. Atomic mass of some common elements. Atomic mass of some common elements. Some elements, their atomic masses we're going to use very frequently. So you have to get it by heart as soon as possible. I'll write the name of the elements in symbol here. Hydrogen, symbol is capital H. Here let us write atomic mass 1 U. Then oxygen, symbol is capital O. Atomic mass is 16 U. Nitrogen, symbol is capital N. Atomic mass 14 U. Sulfur, capital S, 32 U. Sodium, symbol is Na, 23 U. Aluminium, Al, 27 U. Copper, Cu, symbol is Cu. Atomic mass is 63.5 U. Zinc, symbol is Zn, 65 U. Calcium, symbol is Ca, 40 U. Let us continue. Here, number 10. Let's write with red ink. Potassium, symbol is capital K and its atomic mass is 39 U. Magnesium, Mg, 24 U. Only the common elements that we are going to use very frequently. And then we do not write for carbons, very important. Carbon, capital C, 12 U. Chlorine also we do not write, very important. Cl, 35.5 U. Sulfur is there, oxygen, magnesium, iron, let us write 14 iron, Fe, 56 U. Like this. These are some of the very common elements whose atomic masses we are going to use very frequently. So you make it a very nice table for these 14 elements and get it back as soon as possible. And so that's why enough for today. In the next class, we are going to learn this mole concept. Please get ready for the next class.